Welcome back, folks. I'm your host Amit, and in this session we are going to discuss the binary tree pre-order traversal problem. So, given a tree, we need to return the pre-order traversal of its nodes. Let us try to understand what pre-order traversal means. Pre-order traversal means first we would need to traverse the root, and then the left subtree, and then the right subtree. So in this case, our result should be like first we would example 1, first we would need to traverse 1, then we would need to traverse left, there is no left, then right, then we would need to traverse 2, and then we would need to traverse the left, which is 3. So 1 2 3, so that should be our result. Okay, let's see example 2. In this case, like if our root is empty, our output is also empty, and if our root has only one element, our output has one element. The number of nodes in the tree are between the range 1 to 100, and value can vary from -100 to 100. Okay, so recursive solution is trivial. Okay, so let's try to first approach with the recursive solution, and then we can go with the iterative solutions. Okay, so what would be the recursive solution? So we should also have a list. We want to return a list of integer. So we would need to initialize a list of integer. Okay, initialize list of integer with result, numeral list, and okay, and what we would do here is we would traverse the root first. So result dot so we will add this to our result. And what would we add? Okay, so one more thing here, if let's say the root is null, then we would like to return an empty list, and we would in that case not add anything. Okay, so we would add only if root is not equal to null, or okay, if it is not null, then it should have an element, which makes sense. Okay, copy it here, and we would add root dot value, and then after this we would iterate the left and the right node. Okay, left node, and we would traverse the right one. Okay, and in the end we would return the result. Okay, so this is an recursive approach. Okay, what's the problem, man? Okay, so try to pause here and try to figure out the problem. So the problem here is we want to add root value, but this would also like return something to us, and we would like to add this to our list. Okay, did you get it right? So you would need to add all all the elements here, and then we would add all the elements to the from the right. Okay, our answer is accepted. Let's try to submit it. Okay, achieved in 1 millisecond. So this is the recursive approach. Let's also try the iterative approach. So iterative approach here in this case would be we would have a queue because okay, so here not queue, sorry, this is a depth first traversal, and we want to traverse through the left child first, and then the right child, first the root, then the left child, and then the right child. So for the iterative approach we would have a stack. Okay, let's have a stack of type tree node. Okay, and in this stack we would add this tree node. Okay, and we would add the element in the stack. So we would iterate the root, and we would add the left and right element. Okay, so if root is not, we would add it to here, and we will start a loop. So the loop would run while till the stack is not empty. Okay, till it is not empty. Okay, and before starting here we would push the first element in this stack. So stack dot push, and we would push the first element, which is root. Okay, then we would see, like, if root is not null, then we would process it. Okay, and before that we would pop from stack, and we would get the tree node, which is a node. We would pop that element, and we would process that, and by processing I mean we would add it to the result. Okay, and this we would do. Okay, so if root is null, we should not even push it to stack. Let's check the condition if root can be null or not. Number of nodes. Okay, it can be 0, which means the root can be null. If root is null, then we would return from here itself. If root is null, return a result. Okay, and if root is not null, then push it to the root and get that node, add that to the result, and again push it to the stack. Okay, so here, very important thing, we should put the right element first, the right node first. Why should we add that right node first? Okay, and here also, like, we should check if and we should add that right node to only if that is not null. Okay, so if root dot right not equal to null, stack dot push root dot right. Similarly we will do for the left. So the idea behind pushing the right element first is because whatever we push at the end no, in the last. So if we push left in the last, then left would we would get left first, and that would be iterated first, otherwise right first. So we want left to be processed first, so we would push left in the end, and then again we would add that to the result. Okay, with this, let's try to execute it. Okay, time limit exceeded. So try to pause here and try to figure out what can be the possible problem here. Okay, were you able to figure out the problem? Okay, I think the problem is we are pushing a node, we are picking a node from stack, so we cannot check root, right? So we should be checking node dot left, node dot right instead of root, because otherwise it's getting into an infinite loop, like loop kind of a thing. Okay, let's try to run it. We get wrong answer here. Let's try to figure out what's wrong here. Okay, I think you might have got it. Here also we need to add node.val instead of root.val. Let's try to run it. Okay, our answer is accepted. Let's try to submit it. And with the iterative approach, we get our answer in 1 millisecond, which is better than 99.83%, 38%. Okay, thank you folks. See you in the next one.